Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the fall 2021 semester. This is the Cisco Networking Academy's CCNP ENARSI version 8 course curriculum, and in this Packet Tracer tutorial and activity, we're going to be taking a look at Packet Tracer Activity 21.2.1, where we're going to be configuring extended IPv4 access control lists. Now, this is another one of those soft landing activities, as I like to refer to them, because it's going to be providing us with a number of the commands that are going to be required. However, we're going to be discussing the semantics around a number of those commands, specifically the directionality when applying ACLs. Should it be an inbound ACL? Should it be an outbound ACL? As well as location of the placement of the ACL. Remember, with a standard ACL, we want to place it as close to the destination as possible. With an extended ACL, we want to get that as close to the source as possible. And so let's see how things play out in this activity and whether or not we're following those best practices. Now you can see here, I've got us into global config mode, and we're all set and ready to go with the walkthrough here for the access list command. However, before we do that, let's go ahead and take a second, because it's going to be worth our while to discuss what the wildcard mask would be for each of these three subnets. And you can see here, we're going to be dealing with the same network. It's simply been subnetted into a /26, a /27, and a /28. And that network is the 172.22.34. So how easy is it to figure out what your wildcard mask should be? Well, all you need to know is your subnet in dotted decimal notation. Well, from CIDR notation, it should be pretty easy for us to figure out what the last octet will be. We're going to go ahead, and we know that the first three octets would be all 255, so we don't need to write all of that out. Let's just go ahead and deal with what the last octet is going to look like in the subnet mask in dotted decimal notation. Well, if it's a /26, that means the first 26 bits have been borrowed for network bits. And in the last octet, the fourth octet, it would look like the following: 11 followed by the host bits. Again, we're borrowing those first two high order bits in the last octet for network bits. So 1, 2, 3, 4, 5, 6, 7. I need one more here, and 8. And so in dotted decimal notation, the subnet mask here would be .192. So how do I get the wildcard mask? Well, remember, the wildcard mask is the inverse of the subnet mask, and then we subtract from all 255s. And if I was to do that, if I was to say 255, and I apologize, that's a little tough to see there, but I'm writing 255 right up here. If I was to subtract 192 from 255, what would we get? Well, we would get 63. And now we have our subnet mask. Again, we know that the first three octets of the wildcard mask, since the subnet mask is all 255s in those octets, the wildcard mask is going to be 0, because 255 subtracted from 255 is 0.0.0.63. So here is the wildcard mask in dotted decimal notation. Now, we could repeat the process down here. If it's a /27, we know that we're borrowing the first three bits, the 128, the 64, and the 32. Well, 128 plus 64 we already know is 192 from above. And then 192 plus 32 is going to be 224. And then let me go ahead and put the 5 host bits in here. So it's going to be .224. And what do we need? And again, we don't need to subtract. We could do it in the reverse direction. What would I add to 224 to get to 255? Exactly, I would add 31. So the wildcard mask in dotted decimal notation would be 0.0.0.31 for a /27. So we have our wildcard mask there. And then we take a look down here, /28. So again, we just kind of continue to build. So we're borrowing the first 4, in fact, all high order bits here in the final octet, leaving us with 4 host bits. And 128 and 64 is 192. We know that from the first network, the /26. And then 192 plus 32 is 224. We know that because of this network here, the /27. And then we add 16 to the 224 to get 240. And so if it's 240 as the final octet for the subnet mask in dotted decimal notation, what do I need to add to that to get to 255? And that's a simple mathematical equation, and we know that it's going to be 15. And so there is the wildcard mask for the /28. Now I'm going to leave this up here because we're going to come back. We're going to need to refer to this as we work our way through here. So now let's go ahead and pick up where we had kind of started, which is the access list command. And you can see that standard ACLs, when numbered, range from 1 to 99, and extended access lists range from 100 to 199. Now, there are expanded ranges for both of those as well. If we were to pull router number 9 up here, we could see that by simply going into global config and saying access list and doing a question mark. And as you can see, there are far more options, many more options here. There are many more options here. And so here's what we see in Packet Tracer. Again, for a CCNA level, this is good knowledge to have. But here is the expanded range for the standard ACLs, and that's going to be 1,300 to 1,999. And here's the expanded range for extended ACLs. And those terms, be careful with those terms. You'll notice I'm stressing the expanded range, right? I typically don't refer to it as the extended range, because if I was to say the extended range for standard ACLs, it might get a little confusing there. Well, wait, is it an extended ACL because it's in the extended range, or is it a standard ACL in the extended range? How does that work? So it's the expanded range, right? The range is expanded, and you have an expanded range for standard ACLs, and you have an expanded range for extended ACLs. Kind of a little tongue twister there. So let's dive back over here and take a look at what they want us to do. Well, we're going to use number 100. And that again, because we're creating an extended ACL. Now, oops, and I guess we'll do a question mark here. So what can we do? I can deny, I can permit, or I can put a remark in here. And so here's what we're going to do. And it's interesting. I feel like I'm getting some feedback here on the microphone with respect to what I'm typing in. So I apologize if there's a little feedback coming through. So we're going to say access list 100. I'm going to do a... Yeah, so when I'm doing the question mark, I'm actually receiving some kind of a voice over here. So give me 1 second. And this was not something that was happening previously. I just want to make sure that we don't have anything set. Okay, so let's go ahead. We'll continue. Whoops, sorry. We'll continue through on this activity. Let me drop this back down here. Yeah, it just sounded like it was getting some feedback there from the activity itself. All right, so access list 100 permit. And if I was to do the question mark, you could see we would end up with EIGRP, all kinds of different choices that we could pick from here. So we're going to be permitting TCP. Yeah, I am getting feedback. So for some reason, Packet Tracer is actually reading out all of these options, and I'm not clear as to why it's doing that. So we're going to continue through. I'm going to skip the question mark portion of things here, and we're just going to follow the activity as it's listed out here so that we don't need to listen to all of this feedback. Now you can see here they take you through sort of a long-winded version of getting to the wildcard mask. However, we end up in the same spot. So let's go ahead and I'm going to actually bring it all the way down here to the end of sort of step number 1. And so what we have is access list 100, permit, and we're going to say, TCP, and then it's going to be from, and this is the source address. So we're permitting transmission control protocol traffic, and again, that TCP marking is going to be in the IPv4 header from the 172.22.34.64 network, right? So you can see we're going to be permitting TCP traffic from this entire network range right here. And again, you may be wondering, well, how many hosts could we have in this subnet? Well, remember, we've got 1, 2, 3, 4, 5 host bits. 2 to the 5 is 32 minus 2. We're subtracting 2, 1 for the broadcast address and 1 for the network ID. So we could have 30 hosts in this range. So for these 30 hosts on this, theoretically on this subnet, and let's get our wildcard mask in here, .31. And again, you can see there we have that correct. Going to the host, and so this is a /32. Now there's two ways that I can say this. Remember, I could say host 172.22.34.62, or what I could have said was 172.22.34.62 0.0.0.0. Now, I've got to tell you that I am a huge fan of using the keyword. It just reads so much easier, right? So we're going from the 64 subnet, the 172.22.34.64/27 subnet, going to this destination address, 172.22.34.62, which is our server up here, and that is going to be equal to FTP. So FTP traffic from PC1's subnet is going to be allowed to go to the server. Now we're going to create a second ACL set. And hold on one second. I need to figure out what's going on here because it keeps reading out the commands for me. So I'm going to pause this real quickly and then we're going to be right back. All right, so we're just going to continue to power through here. And for whatever reason, if you hear any feedback, I apologize. I'm not sure what's going on. It's Packet Tracer is just literally speaking and it's giving this text-to-speech kind of thing, and there's no way, there's no option to turn this on or off under the preferences. So we're just going to continue to power through here. So there's our ACL. So let's go ahead and add the second line in, and this is going to be for Icmp traffic. So access list 100, permit Icmp, and again, that's the protocol that we're going to be permitting through from, once again, that 172.22.34.64 network that we know has a 0.0.0.31 wildcard mask going to the host 172.22.34.62. And let's go ahead and add that in there. And so there's that command. And now we're going to execute the show access list command. So let's click in and let's do a write mem. We're going to save our config. And I'm going to say show access. All right, so I just went ahead and turned the volume off. Again, I can't figure out why it's reading back my commands to me. So anyway, we've got our access list. Here it is. And let's now go ahead and apply this ACL. So we're going to get back into global, back into global config here. We're going to go into interface, gigabit Ethernet 00. Now remember, gig 00 is the inside interface on router 1, and this interface is the closest to the source. And that is what we want with an extended ACL. Again, it's a best practice. It's not a hard and fast rule. It's not you have to have the extended ACL as close to the source as possible. However, if you can achieve that, right, if it's doable, that is considered the best practice. So now let's go ahead and apply this ACL with the IP access group 100, and we're going to do it in the inbound direction. Again, the directionality is key here because what we're saying is traffic is going to be coming into this interface. And the only way that traffic comes inbound on that interface is from this subnet right here. Again, and that's why we have that subnet listed first, because the source comes first in the ACL, followed by the destination network, or in this case here, the destination host. And that is the inbound direction. So let's go ahead and make that application final here. in the inbound direction, and there we go. And as you can see, it took us to 50% in terms of the completion percentage. So let's go ahead and test our FTP. We're going to open up PC number 1 here, and let's give ourselves a little room with which to work. And we'll float this over here, and let's just go ahead and say FTP to the 172.22.34.62. And there we go. We are connected. And let's see. Oh, it just wants us to go ahead and quit out. I just want a username. So Cisco and Cisco. There we go. So we're in. And then I can just quit out. All right. So as we can see, FTP is working. So now we've got part 2 of this lab. And part 2 of the lab is going to require us to configure an ACL to permit HTTP and Icmp from the PC2 LAN, so from this LAN over here. So let's pull router 1 back up, and let's get back to work here. So IP access, oops, sorry, not IP access group. I got to get out of the interface configuration mode. So we're going to say IP access list. I'll do a question mark. You can see here again, we can have standard or we can have extended, and we are going to go ahead and do a named ACL. And that's why we started this command with the IP keyword. Previously, we just said access list 100. Here, we're saying IP access list extended because it's going to be a named ACL. We're going to call it HTTP underscore only. And what we're going to do here is we're going to permit TCP, and it's going to be coming from this network here. Again, we could do it from this single host because there's only one host down here. Just like over here for PC1, we could have used the host statement and done only this host. However, they wanted us to use the wildcard mask, and they wanted us to allow it for the entire network because maybe the network's going to grow. You know, these switches probably have more ports. We could put more PCs in there. So we'll say permit TCP 172.22.34.96. That is the network ID. The wildcard mask over here is 00015, and you can see that we did get that right up here. And going where? Well, going to the host 172.22.34.62. And what are we looking for? We're looking for the destination port number that would be 80. So we're only talking about HTTP. We're not talking about HTTPS at all, right? So we're permitting TCP traffic from the 172.22.34.96 subnet, the entire subnet with a wildcard mask of 00015, and we're allowing that traffic to go to the host 172.22.34.62 if and only if the port number is 80 for www traffic. And we're also going to permit Icmp traffic from the 172.22.34.96 network with a wildcard mask of 000.15 going to that same host so that we can test with ping 172.22.34.62. And let's go ahead and hit enter. And as you can see, we now have the wildcard. We now have the extended ACL all configured. If I was to punch out of here and say show access lists, there are the two extended ACLs. We have a numbered ACL and we have a named ACL. You can see with the FTP, we've already got some matches here. Now, another key thing to remember about access control lists is they are not stateful. They are stateless. They are not keeping track of conversations that are going back and forth. They're simply counting packets. That is what they are doing, right? So remember, ACLs are stateless packet filters. That's all they're doing is they're filtering packets. They're looking at each packet as it goes through. So again, on an extended ACL, we're going to get into global config. We're going to go into int gigabit Ethernet 01. We're going to say IP access group and HTTP only, underscore only, and which direction, in the inbound direction, in the outbound direction. Now, a lot of people get confused because they think, oh, it's in the outbound direction because it's going out to this network. Well, no, remember, we're not talking about it from the point of view of where we're going to. We're talking about it from the point of view is where is the traffic going to be coming from that would hit this interface that we wish to match, and the answer to that is it would be coming in from that subnet. It's the point of view of the source network, and how is that going to hit this interface? Well, it's going to hit it in the inbound direction. Outbound, it would be coming this way. And that is not how we have our ACL set up to work. So it's going to be, again, in the inbound direction. So HTTP only in. All right, let's save our config here. And how can we test that? Well, very simply, we would pull PC2 up. We would pull up our web browser on PC2, and we would say http://172.22.34.62. And take a look at that. It works. Now, what about over here on PC1? What if I was to try to hit that from PC1? And in fact, I could just type 172.22.34.62. And let's see. Clicking go, and nothing is working. And the reason that nothing is working is because we are not allowing that traffic out. Remember, at the end of every ACL is an implicit deny all, right? And deny everything else. So if it's not implicitly allowed or permitted, it's denied. So in other words, the extended ACL that we have applied on router 1's gig 00 interface is only allowing FTP traffic out and only allowing Icmp traffic out, meeting these requirements, in other words, coming from the PC1 subnet, going to the server. So here's my question. What if I was to try to ping from PC1 over to PC2? Is that going to work? Are we allowing ping to go from PC1 to PC2? So let's check it out, 172.22.34.98. And the answer is we are not. And the router is replying back to us, telling us the destination host is unreachable. And that is not going to work. And the same is true on PC2. If I was to try to ping PC1 by saying ping 172.22.34.66, are we allowing ping to go there? And we are not. The only ping traffic that's being allowed from either of these two subnets are Icmp requests going out to the server. And that is it. So ping requests between each other are not allowed. Remember, there's an implicit deny any or deny all at the end of every ACL, irrespective of whether it is standard or extended. All right, well, I apologize for the packet tracer reading back the commands there earlier. We got that sorted out, and that is going to do it for packet tracer activity 21.2.1, where we took a look at extended IPv4 ACLs, talked about the semantics. We want to get them as close to the source as possible, whenever possible. That's a Cisco best practice, not a hard and fast rule. And we took a look at how you could do the host application with the quad zeros wildcard mask, or with simply the host keyword. And then we talked about looking at how the traffic is sort of being logged with the ACLs. All right, well, that's going to do it for this activity. Thank you so much for watching. And as always, I hope to see you in the next video.